Hi, welcome back. We are still on Unit 10, Day 7. Oops, sorry. We are on Unit 10, Day 7. I was trying to zoom in and I rotated myself around. Surface area and volume of composite three-dimensional figures. We looked at some composites. It's going to be multiple shapes put together. We've already looked at how we're working with surface area and dividing up, and you have to pay attention to which bases you need and which bases you don't need. With volume, it's a little bit more simple because you don't have to worry about where your bases are. You're just filling stuff up. So you will need to find each volume formula so that you can fill those in. So you still need to identify what your shapes are. So when I'm looking at this, the first thing I see is I have a cone on top of a hemisphere. So I have a cone, and then I have a hemisphere. Okay, so the first thing I need to do is I need to look at my formulas for volume for cone and hemisphere. So for my cone, if I go back and I look at my formula chart, which is right here, my volume is my last column, and my volume for a cone is 1/3 pi r squared h. 1/3 pi r squared h. 1/3 pi r squared h. And my hemisphere is going to be half of a sphere. So my sphere for volume is 4/3 pi r cubed. 4/3 pi r cubed. So I need to know the radius of the cone and the hemisphere, and I need to know the height of the cone. So my radius of my cone is 39 feet. I can see that there. That's given there for me. So when I'm looking at my cone, 1/3 pi times my radius, 39, squared, times my height. So I have to figure out how tall is the cone. Okay, well, I can see the whole distance here is 81, and it might be kind of tempting to divide that in half, but I can't do that. When I look at the sphere, the hemisphere, I know the whole hemisphere all the way around, every radius inside of it is going to be 39 feet, right? So if I were to extend my radius straight down vertically to the bottom, that would be 39 feet for the hemisphere portion of this figure. So then when I want to figure out, okay, what is this top portion? I know together these make 81. So I'm going to do 81 minus 39 to figure out what this height is. So I'm going to grab my calculator. 81 minus 39 is 42. So I know the height here is 42. Okay, so that way my 42 and my 39 make the height of the whole composite figure 81 feet. Okay, so now I'm going to do my cone. I'm going to get my exact area. So I'm going to do 1/3 times 39 squared times 42. Notice I didn't put the pi in here, so when I write my answer, I still need to write pi sitting out next to it. So I have 21,294 pi. Now I'm going to come over here. I know that 1/2 of 4/3, we did that when we did our notes. 1/2 of 4/3, 1/2 of 4 of them is 2 of them, right? So 2/3. Or we could do 1 times 4 and 2 times 3, 4/6, which reduces to 2/3. Pi times my radius cubed. The radius in my hemisphere is also 39. So I'm going to put this in the calculator without the pi. 2/3 times 39, and then to raise to the third power, remember we use this little up arrow under the clear, and that moves my cursor up so I can put the 3 there. If I had something else to put in the calculator, I would just right arrow to move out of my exponent. But I don't, so I can click enter, and I get 39,546. And since I didn't put pi anywhere in my calculator, I still have to write the pi out to the side. So my total volume then is going to be the sum of my two pieces, my cone and my hemisphere. So I'm going to add 21,294 pies plus 39,546 pies. That's going to give me 60,840 pies. A lot of pies. That means my approximate answer is, if I multiply this by pi, so I take that last answer that I had and I multiply it times pi, which is right there in blue, so second that up arrow. When I hit enter, I get 191,134.497. And these are feet and it's volume, so it's feet cubed. Feet cubed. There are my two answers, my exact answer first and my approximate answer second for volume. Okay, come on back in the next one and we will talk about what to do if part of your shape is missing. So instead of putting two shapes together, we're going to take one shape out of another shape. Okay, so come on back for that last video where we're going to talk about taking away part of a composite figure. All right, thank you so much for watching.